we are moving on to 4-3, which is multiplying and dividing real numbers. You'll probably find that this is easier to you than adding and subtracting, but hopefully those are pretty easy for you now. Okay, so with the same idea of negatives meaning the opposite still applies. So I want you to still have that first and foremost in your mind because it will make this very simple. So that negative in the realm of math means opposite. Okay? So, with multiplying and dividing, if you figure out the sign for your answer first, and then just do your multiplication or division, easy. Simplest way to do it. Okay? So, we'll start. So, 3 times 5 is just 15. We know that. Okay? So, here I have a negative. It's being multiplied by another negative. So, it starts as negative. This one makes it go opposite. So, a negative times a negative is a positive. So, you can write down your positive. Forget about the signs now. And just multiply your numbers. 3 times 5 is also positive 15. Here we're starting with a positive. It's being multiplied by a negative, which means opposite. So the opposite of a positive would be a negative. 3 times 5 is 15. So 3 times negative 5 is negative 15. Okay? Same thing. We're starting with a negative, multiplying it by a positive, which means it keeps the same sign. So my answer is negative. And 3 times 5 is 15. You can make yourself a little chart over here on the side. And really the easiest way to think about it is if you have 2 positives being multiplied by each other, or 2 negatives, those answers are going to be positive. If you multiply a positive times a negative, or flip that around, a negative times a positive, your answer is going to be negative. Okay? My advice to you is figure out your sign first, then just worry about the numbers. It's much easier. Okay, so I've got a positive times a negative. That's going to make that go opposite. So I know my answer is going to be negative. So I'm going to put that way down here. And now I can just do my multiplication that I would normally do. So that's 37. 2 times 4 is 8. 140. So I would get, let's see, 0, 5, 8, 1. And I need to put 2 decimal spaces back in there. So I get negative 18.50. I've got a negative times a positive. I know my answer is going to be negative. When I'm multiplying fractions, I can just multiply top to top and bottom to bottom. If I can simplify first, that's always easier. So 2 goes into 2 once, 2 goes into 4 twice. So now I just have 1 times 3 on the top, which is 3, and 5 times 2 on the bottom, which is 10. So my answer is negative 3/10. Moving along, we've got a negative times a positive, so I might know my answer is going to be negative. Now I just have to worry about the numbers. 4 times 4 is 16, and 5 times 1 is 5. It really is that simple, and I know it seems like it's going kind of quick, but I don't want to make it any more complicated than it needs to be. So we've got a negative times a negative. So it starts as negative. This negative makes it do the opposite, which means my answer is going to end up being positive. Now we can just multiply our fractions. Let's change this into an improper fraction. So 4 times 1 is 4, plus 3 is 7. And we're going to multiply it by 4/3. I already know my answer in the end is going to be positive. That's why I didn't bother writing any signs here with this, because I've already figured that part out. 4 and 4 cancel out. So I've just got positive 7/3. When you have positive numbers, you can either write the positive down, or you can just leave it off. Either way, your answer is correct. If you need to write the positive for a while, do it. It's not a problem. All right, so we've got a positive times a positive within our square root. 3 times 12 is 36. And then square root of 36, which means what number times itself gives you 36, would also be 6. Now, with square roots, they're kind of an interesting thing because 6 times 6 equals 36. But negative 6 times negative 6 also equals 36 because a negative times a negative is a positive. So many times you will see square root look like positive or negative 6. Depending on what type of math you're doing, you only worry about a positive root, which we call the principal root. Won't really apply to you for a while, but you'll just have that in your wheelhouse of knowledge for when you need it. All right, so let's look at commutative property of multiplication and associative property of multiplication, exactly like it was with addition. If you multiply A times B, it's the same thing as multiplying B times A. So 3 times 4 is the same thing as multiplying 4 times 3. 3 times 4 we know is 12. 4 times 3 is obviously 12. Okay, so what you're really doing is, do I have 3 rows of 4, or do I have 4 rows of 3, right? Same number of dots, I'm just flipping them a different direction. One's horizontal, one's vertical, but exactly the same number. Okay, associative property happens when you have more than 2 factors that you're multiplying together. So, and again, oops, not addition. Again, it's just how you group them. So, A times B times C, grouped with the A and the B multiplied together first, would be the same as A times the grouping of B times C. So if we put some numbers in for that, let's just do easy numbers. So 2 times 3 times 4, and let's group that first, those first 2, and then 2 times 3 times 4. Okay? And then let's check to make sure that works. So 2 times 3 is 6, times 4 gives us 24. 2 times 3 times 4 is 12. Well, 2 times 12 is also 24, so they are in fact equal. That's associative property. Okay? Division follows by exactly the same rules as multiplication. So exactly this little chart that you have up here applies to multiplication and division, because remember, division is just the reverse of multiplication. So again, you can figure out your signs first, then you don't need to worry about any of it. So let's go ahead and do that with all 4 of these, okay? Positive times a positive is always going to give us a positive. Positive divided by a negative, this makes it take the opposite sign, so it started as a positive, it switches to a negative, so that answer is going to be negative. When you see a fraction like this, the negative applies to the entire thing. So this could also be written, depending on where the negative is, as negative 8 over 2, or 8 over negative 2. All 3 of these are a representation of the same thing. So, you have a negative, when you're divided by a positive, it keeps the same sign, so that's going to stay negative. You have a negative divided by a negative, you get a positive. So now we figured all of our signs out, now just worry about the numbers. So 8 divided by 2 is 4. We know that to be true for all 4 of these. And there you go. Alright, so we can go through these, and like I said before, just take care of your signs first, then you're just dealing with the math. So positive divided by a negative is a negative. Now you can just go through and do the division on that. And for that, we can actually use a calculator. That's fine. And we'll just do 12.4 divided by 3.5. I don't even need to include the negative on there because I know that 5, 4, we can round it off to a couple spaces. I already determined that it was negative, so I don't need to worry about that anymore. Negative divided by a positive, I know my answer is going to be negative, so I can just ignore that. Dividing by a fraction is the same as multiplying by the reciprocal. The 9s will cancel out, so I get 2 over 4, but that's going to reduce to 1/2. My answer is negative, so my answer is negative 1/2. Negative divided by a negative would be a positive, so 3/5. Dividing by 2/3 is the same as multiplying by 3/2. So 3 times 3 is 9, and 5 times 2 is 10. Alright, let's change this to an improper fraction. We have a positive divided by a positive, so I know my answer is going to be positive. So 2 times 4 is 8, plus 3 is 11. Dividing by 4 is the same as multiplying by 1/4. So I get positive 11 over 16. Okay, let's do absolute value. So let's take care of the inside first. We have a negative divided by a positive, which is going to give us a negative. 21 divided by 7 is 3. And remember, the absolute value means how many spaces it is away from 0. So the absolute value of negative 3 is 3. Alright, so you try these 2 on your own and then come back and check your answers with me. Okay, so I've got a positive divided by a negative, so my answer is going to be negative. 5/4 divided by 5/6 is the same thing as multiplying by 6/5. My 5's cancel out. I can reduce my 4 and my 6 by 2. 2 goes into 4 twice, 2 goes into 6 3 times. So my answer is negative 3 over 2. Alright, negative divided by a positive. So you only apply that absolute value after you've taken care of that multiplication. So, the same as multiplying by a third. So I get the absolute value of negative 4 over 21. So your answer would be 4 over 21. Good. Is there a commutative property of an associative property of division? Well, there is if you think about the fact that multiplication is the reverse of division, but technically, no, we don't have a commutative or associative property of division. Just say no, but the multiplication properties apply. Okay. All right. So these two down here, we haven't really dealt with anything with variables yet, but I'm going to show you how you can deal with these. So if this was 8 minus 12 over 4, you can actually split this into two separate fractions. It would look like 8 over 4 minus 12 over 4. The only difference is now we're adding that variable right in here. So you can divide both of these individually. 8 divided by 4 is 2, and tack on the x, and then 12 divided by 4 is 3. Now, you cannot combine these two things because this has a variable with it, has the x with it, this does not. You can only put things together that are the same. So you're just dividing each of those components by the denominator. Doing the same thing here, you can split this into 2x over 3 plus 9 over 3. And when you simplify that, this can't simplify any more than it does, so you can write it as 2x over 3. You could also write it as 2/3 x. Those are both fine. Plus 3 and plus 3. All right, that's 4/3.